Right. Then let's have a look what's up on the agenda for today. So we have as a first point FPM integration with VS Code. Yes, want to go ahead?
Yeah. Sorry, I was setting up my desk. Yeah. So I don't know if it's gonna happen now, or whenever we get funding, or in next GSOC or whenever. But probably we should have a plan of how FPM should integrate with modern Fortran, and I guess other editors as well, because we don't know what's going to come next. I have a couple of ideas. Let me pull up the GitHub discussion. But one option is to take a page out of the book for the C++ extension. So they have a configuration file, and that configuration file holds all the settings for all different build systems. I think we can do that for sure. Okay, let me show my screen. Finally, I'm ready. Share screen. Yeah, so you should be seeing the discussion. So and there are a few ways that can be done. So like, as I said, one is with a proprietary JSON-like file. I think that's a lot of work. So what we could do instead is we could bend modern Fortran to our will and make it understand FPM tuples. I think the projects have a very standardized structure, and that is relatively easy to do. Now, obviously, there's the UI aspect of the whole operation, which is designing, and I'm gonna try and show you how CMake does it, which is designing an activity bar icon on the side, figuring out what things should be there, and other stuff like that, I guess. So for example, CMake does this. Sorry, give me a second to just hide this. So this is CMake. I don't know if you can see it. Yeah, that's better probably. So this is CMake, and whatever targets you have will be detected here. This is just one project. And you can configure your project, you can build it, and then you can edit the actual CMake cache. And that is I think the highly verbose one. So FPM doesn't have that. So the idea would be to probably create an intermediate file, like a CMake cache or an FPM cache. I mean, FPM has a cache, but it doesn't have a file where you are allowed to specify a lot of additional settings. So that is one. Yeah, so basically all of register, the sidebar action, and blah, blah, all of this is copy paste from CMake. And then allowing setting options to FPM through the UI is what I mentioned. Some of the options will be in the actual FPM. Some of them probably will be in the allowing setting options into that additional file, which is the 0.6. So points 5 and 6 are complementary. And then any additional options we might want. I don't particularly think that there are a lot of options that we should be able to specify on our settings and not in the FPM itself. And then what we need from FPM is I think we should keep our builds the way they are, but for linting and project setup, we should be able to dump all the mod files and sub-module files into a deterministic path, because these get generated whenever you lint, and you don't really want to use those for your compilation. Yeah, so there is that is the summary of what what I think we should be doing. Yeah, and given that all of the configuration settings will be on the FPM itself, we won't be parsing any of we won't be duplicating any of the FPM set functionality on VS Code. It will be easier to extend it in the future, I think, instead of creating a copy of whatever build system in modern Fortran. So we effectively we will be querying FPM for everything. And the only thing that we really have to do is parse FPM toml to something, to probably JSON, because JSON is what JavaScript understands very well, to extract some quantities, like include paths, like preprocessor flags. And yeah. And then there's the bigger discussion of integrating the rest of the tools in that. But I think that's for another time. What do you guys think?
So having done this twice, I did it. I made one for Atom and I made one for Visual Studio. I like the CMake UI design where they have that extra icon in the sidebar, and then it opens the settings and in that extra sidebar. That I like that aspect. The way I've implemented it a couple of times is basically having the settings or options that kind of mirror the command line arguments to FPM. The thing that I didn't get around to doing was basically have FPM tell me what the targets are, because that's a capability, right? So you don't necessarily need to parse the toml file to figure that out. In fact, the toml file may not be sufficient because it may be auto detecting what some of the executables are. So you want to get FPM to tell you, hey, here are the run targets, here are the test targets, here are the example targets, if you want to actually execute. And then I'd like to have FPM put mod and smod files in a particular location for linting purposes. Is there a reason you need them to be somewhere else, or is it okay that it builds them right? Because FPM will keep them up to date if they happen to interact with the actual build that the user is going to use, right?
It is rather problematic, I think. A lot of people have problems, and I've had problems definitely in my PhD in the very beginning, where I didn't understand how the linter affects your build. So I am of the school that your developer tools should not be interfering with your build distribution, like with your compiled code. So you're developing, you might make mistakes. You probably want to always be developing with debug options and debug symbols. So in case you want to do something quick, but I wouldn't really use the output of the binaries or the compiled object from the linter for a build. I basically it might be dirty, and it very often is. So we can do other things. We can do build on file change. We are able to watch files in our workspaces, and we can trigger FPM on that asynchronously. Yeah, so that is the solution that I would have, but I would try and keep away the linting parts from the build parts, because I mean, you never know. Specifically for my case, I've had multiple bugs with external libraries, but because I kept mixing two different builds. Yeah, so I would like to keep them separate.
Okay. So it would
one
make
fi-
sense to have this be a feature request for FPM to say, I would like to build over here, like put the output in a specific spot.
More like copy my build files to a location. So I've already taken away the VS Code. VS Code by default used to dump all your mod files and everything generated into the working directory, so where the actual source file was living. I took that away, and unless you've specified a setting of where to dump them, it dumps them in a cache somewhere that is project specific. Obviously, that path is horrible. And if you look at the debug logs of the extension, you're going to see a massive path. But it helps ensure that, oh, my mod files are being placed somewhere that will not affect my compilation. So, yeah, sorry, go.
If you use a default in FPM to say, okay, I have this linter, so I'm using Fortran for linting, and I want FPM to discover all the files which are part of my project, and I want to have all the logs from Fortran. FPM will by default use debug settings. And if you say, okay, I have specific options I want to use for this linter, you can pass those to FPM, and FPM will make sure that those files will end up in a different path than used for any other build. So in principle, you are safe. And you could even go further. You say, okay, I rely on FPM doing this right and reporting back to me either the logs or the position or the paths of all the mod files from this build. And FPM should be able to do this for you.
Okay. So, ultimately, what we want, yeah. So what I'm thinking is the linter is not going to run FPM, right? So the linter is going to run Fortran because it checks each file individually versus the compiler, and just does a mock compilation.
Now imagine you have the setting. You take an FPM project with 150,000 lines of code, which is a medium-sized Fortran project, and now you ask this linter, lint this TOML-F module. So is the linter now going to figure out, before I can lint this file, I have to import half a dozen modules, which depend on other stuff. Or you could ask FPM, build a project and report the output for this file.
Yes, but I guess my question would be, how would you communicate to FPM? You would first have to initialize your project, right? So that's the
FPM is stateless in a way. So if you say, this is my compiler I'm going to use for linting, and these are the flags I want to pass, FPM will make sure that once you arrive at this file, everything is okay. And once you do it again, and this file doesn't change, FPM will just report the old log. If you change the file, we'll rebuild only the things which are needed. So I think it's actually a better way to let FPM do the hard job, figure out the dependencies, and then report the things you queried. Of course, in the current state, you can't do this. You can only say FPM, okay, build everything. What you would need would be an API where you can say, okay, I'm going to query FPM for the compile logs of this file. FPM will initialize the build and then return you this information.
If I may, so we can always implement some subsets of this and take some shortcuts, but the ultimate, in my opinion, goal should, and the way I see it, is that linter is just a compiler. It needs to, in principle, have full access to the full code. And you can imagine you can modify some type in one module, and then if you are using it from another module, even if you don't modify the module, it can completely break or change things. Like if you change the DP variable from kind 4 to 8, the whole project changes, stuff like that. In my mind, we are talking about FPM or the build system and package manager interaction with the compiler, and it needs to be much tightly coupled than just well, currently we are launching the compiler on a file by file basis, but the problem is that, let's say in Fortran, we have two modes how to compile each module. We could the default mode is we only compile it to this ASR, the intermediate representation, and then only when you compile the final project, we actually compile to machine code, and so we have access to all your files. But when you think about it, especially for recompilation and so on, it'd be much more efficient if FPMs could somehow communicate the structure of the project to Fortran and let Fortran compile it in parallel, for example, and so forth, maybe. And linting is just like that as well. Effectively, the linter has to know the whole project and what depends on what, and so we should maybe discuss or figure out like what's a good way to cooperate with the compiler that wants to cooperate. Of course, if you call G-Fortran that doesn't currently have knowledge of FPM, then of course you will still be calling it on a file by file basis, or Intel Fortran and so on. But for Fortran, I would love to implement more tighter coupling, and so we should discuss how to do that, and then we can reuse it for linting as well.
Okay, so Fortran, I think already, by the way, so the file by file is a pending PR for Fortran, I think, which whenever it gets merged, people will be able to use Fortran for that. But I guess what we want, do we want the users to have initialized their code, so they already have built their codes and then provide linting on that, or do we want to initialize the code base ourselves and provide some linting afterwards? Because the Fortran could do I think you talk about the second thing, right? Where you just get a fresh project and you figure out the dependencies. You will build any possible files and generate any possible machine code, and you will let the compiler figure that out and not do it on a file by file basis. Right?
More like FPM. Like the way I see it is that FPM knows your project. So I don't care how it builds it and technically how it gets done. But in my mind, FPM knows everything about your project and your dependencies and your compiler options and knows everything. And so it should be FPM's job to just do whatever it needs to do to have everything initialized before calling the linter. And really, I don't think of it as calling a linter. I think the linter is a compiler, let's say, so it needs to cooperate with the FPM. So we will just have to figure out what's the best way to do this cooperation.
We have to keep in mind though, that a lot of people might not have FPM like projects, so FPM might not be possible to be used. So we have to.
It's a separate task. So there are two tasks. One is how to make this work with FPM, and it's a separate task for projects that don't use FPM.
I mean, how does it work now? So if I have a CMake-based project and I'm going to invoke the linter on a file, which depends on a sub-project, which is going to be fetched by CMake on demand, is the linter going to be able to figure this out?
For Fortran, we haven't done anything with CMake because.
Okay, any other build system. I mean, if I have something which is fetched on demand, and as I go into this project, and I say I want to look into this file, I want to lint it. What is going to happen? So if there is a module which is not present in my tree, which has to be fetched on demand by a build system.
So the C++ and C extensions use the language server to provide the diagnostics. So they have gone, they don't actually call a compiler. So at least in VS Code.
And that's kind of my point, is that it's tied to the language server. And so if, let's say with Fortran, I would love to have a language server which handles all these things, including linting. And also when you call it on a file by file, like from scratch, it's very inefficient because the compiler has to kind of reconstruct all kinds of stuff from scratch every time. Sure, it can cache things and so on, but the most efficient way is to just run the compiler in the background and it knows at each point the whole state of your project. And especially if you integrate with the VS Code language server, it knows or can know every keystroke. And so it can just keep your project fully updated at all times. And then when you ask it, lint, give me feedback on this file, lint, just warning, or whatever linting you choose you want to get, then it can just give it to you right away because it already has your project loaded.
Yeah. So I think to answer Sebastian's question, the others don't use a linter. They use a language server with very beefed up diagnostics. So they have gone in their language servers, Microsoft, and the other one is LLVM based, I think. So CLangD, and they have added a lot of diagnostics that you would also encounter in compilers. So because exactly what Andre said, upon initialization of your project, the language server parses everything and keeps that in memory, and it's a running process. So you can do things a lot faster and a lot more efficiently. I kind of have that in Fortran, but there is other work that needs to be done for Fortran for such diagnostics to be served. So I would count on Fortran picking up that work rather than, which is an actual compiler, and can share the error codes with the language server, for example.
So basically two different things we're discussing here.
Yeah.
There's one thing where we want diagnostics served from our linter, which can be a compiler, or which should move in the future to a special Fortran mode, which is working as a language server. So there's the current state where we just invoke the compiler and show the diagnostics, and there's the future mode where we're going to drop all this and move to a language server which is able to do this. And on the other hand, we have FPM support not as a linter, but as a build system, where we want to have integration like the CMake build system, that I can see all the targets, that I can configure the project, and that I can just run an executable. So those are two distinct tasks. So we still want to have the FPM integration independently on how we're going to evolve the linter support in VS Code.
In a sense, but the design decisions made on the build system will affect the linter.
So basically, if we design the build system support well, it can support in an FPM-enabled project the current linting strategy by making sure the compiler is invoked correctly and the diagnostics are passed correctly back.
Yes, and also I think it can if FPM does let me share my screen again. So if FPM does implements the functionality that I not so thoughtfully suggested here. Yeah, these two. Other linters in other editors would probably be able to pick that up. So it's been a while, but I think NeoVim has a linter that does something similar with Fortran maybe. And there are a few other command line editors. I don't know if people use these linters. I really don't. But basically FPM would enable it would allow for the usage of these kind of strategies for other code editors. Anyway.
All we need is to design it so that we don't close any doors. That's kind of the key.
Yeah,
and basically. I think we can always write a wrapper, kind of like a shim language server that calls Fortran underneath, so that Fortran is still being called on a file by file basis. But if our design requires a language server, then we can have even an example language server that just calls Fortran. And as long as it's easy to maintain, that's not closing any doors. So I think we don't have to worry too much about any particular where to put the files, but we have to design it so that it doesn't close the doors. And the doors that I don't want to be closed are so that eventually once Fortran gets off the ground, it can very efficiently give you the linting, not very, the most efficiently give you the linting and diagnostic messages for any file for large project. And and it needs to be, and what I want is I would like it to be completely immediate for much bigger projects than 100,000 lines, million lines, 2 million lines. To kind of give you an idea where I'm coming from, I benchmarked Fortran with our x86 backend, and it can compile, fully compile to machine code about 250,000 lines per second on a single core. On my laptop, I forgot which laptop it was, but roughly. And maybe if we spend a little, maybe it can be even speed up a little bit, but at least that. So a 2 million line project can be 8 seconds on a single core, and on multiple cores in a second to full from scratch. But of course, if you are not compiling from scratch, it should be completely immediate. Now, we cannot be using the LLVM backend because it's very slow to compile. We would have to have our own, but eventually I'm hoping we'll get there. And so what I'm hoping is that you have a large project, you put a keystroke in your VS Code and immediately spits out the binary, immediate if you want that, or gives you the error messages immediately. But to get there, we don't want to close the doors to it. And so I don't know exactly what's needed for the solution. All I'm asking is just we don't close the doors, but it seems to me that for efficient compilation, like I just described, it might be that the compiler might need to maybe FPM needs to give it some kind of a JSON structure of the project, and the Fortran compiler itself would do the actual compilation and then figure out when to compile what. Or maybe FPM has to give it like what files changed, or I don't know exactly where it.
Maybe a suggestion here. From the FPM side, we can do something which I would call a poor man's Unity build. If we figure out the dependency tree, we can chunk files and pass, for example, our compiler like 3 or 4 files which belong together in the right order. And Fortran, for example, if you pass it all the files of the project in the right order, then it will compile all of them. It will take us some time, but we could do something automatically on the FPM side to figure out how the files should be compiled, order them in the command line, pass this command line to the compiler. Then we could have something like a Unity build, which is managed by FPM, but just chunking together files. So this doesn't solve the issue if you have a compiler which can figure this out by itself. So the question is, how should Fortran implement this? And I would say it's a waste of time if Fortran implements this by itself. It might be possible to move FPM into the Fortran runtime and then have something like Fortran subcommand, maybe FPM, maybe package, maybe whatever, and have direct integration where we call the package manager from within Fortran. It might not be the plain FPM which you put in there, but a modified variant, which is tailored for running only with Fortran and running optimally with Fortran. So I think this could be feasible, and then Fortran doesn't have to reinvent a scheduler.
Yeah, I don't want to reinvent. I want to kind of get out the design so that we can just be the most efficient, split the work the most efficiently. Of course.
So
and passing a big JSON file from FPM to Fortran, having FPM produce and Fortran read it, is kind of silly if we have a Fortran runtime, which we could just load, in which can contain FPM. I mean, why not? There's already a Fortran runtime in Fortran, so why not?
And by the way, going with this idea further, Julia has the package manager directly in kind of available as kind of a part of the runtime library. Like Python has a runtime library and Julia too. And in Julia, in the interactive mode, you can then, I can't remember the syntax, but there is a way to communicate with the package manager. You do like package add or something, and it just adds the package. Well, I would like that for Fortran as well. So you run Fortran interactively, you do maybe even use a module and it will figure out which package it's in and tells you call, or maybe you will switch to a different mode and then it will say add my package, whatever. So it should communicate with FPM and to do all of this. And we just have to figure out how to do the communication.
So I might not have the answer on how to do the communication, but the language server for our Fortran will have to figure out the dependency trees. So if we are to leverage FPM, it will have to be at the initialization of the server. So at that specific part. And when you figure out the tree structures, you can do whatever you want with it. So, and it will only have to happen once, I think.
No, I think it has to happen all the time because it changes. You add files, you remove files.
Yeah, sure. You after that you start watching the files, but you run the initialization bit once, and then you incrementally update it. So you generate the all the ASTs and ASRs, whichever we decide to store, into a dictionary, and then each of that contains a dependency tree. At least that's how I did it. So each file has its own dependency tree for use modules.
Sure, ASR has dependency trees for that already, but
Yeah.
You are right that we can keep updating the ASR automatically, but I guess in my mind it's still not clear how, because the FPM you still have to communicate the structure to FPM. If you add a dependency or a module or something, as we discussed, FPM needs to be able to still work with the project at all times as well.
My suggestion would be, let's start with making integration for just the FPM build system. See how we can, what is needed for FPM to communicate the very basic things. We don't want to have a deep integration first. We just want to get the basic information from FPM. So, which means whatever VS Code is doing, if it discovers an FPM project, the first thing it has to do is to run FPM, regardless of what's going to happen. If it wants to extract any information from FPM, this is not going to happen unless FPM is at least run once. And this is something we have to account for, and I think it's okay. FPM can run once. So if you enter your FPM project and you say you want to build it, or you want to do something with it, then you have to invoke FPM. So this is, I think, something we can take for granted, that if we are working with an FPM project, we will always have it initialized, because FPM is stateless. We can just call it as often we want, and if nothing is to do, it won't do anything.
Yeah, and in my mind, I would like FPM to handle all this file system stuff and dependencies, everything else. And in Fortran, I would just like to focus on the compiling. So I would like FPM to just give me the files. We can discuss if it needs to give me dependency, because I can figure it out too. But give me the files, give me how they should be compiled and when and what. But I don't want to care about any dependencies, none of that. I would like FPM to somehow handle it. And I think FPM has the model, like we designed it a couple of years ago with that model. So that's ideally all the information FPM needs to know. And so we can just maybe serialize it to JSON or whatever, or communicate that information.
Yeah, no, yeah, I agree with that. I'm trying to find I think I asked Sebastian either on Fortran Lang or somewhere in GitHub about leveraging the FPM build system generically to figure out the build order. I just don't remember where it was.
In principle, we can, we talked about the model. I think the model is based on the Lisp-like syntax, which requires a custom parser. But in principle, it can be serialized in any format.
Well, that's just a particular serialization that we use. It doesn't have to be that way, but it's just a set of structures in Fortran. That's all there is to it.
Yeah, so, and also being able to actually query just that bit of information without everything else, right?
And this, I guess, it can be possible. We just have to figure out which format we want and which queries we're going to allow. Depending on how generic it should be, we might end up implementing something larger. If it's just some very generic stuff, then it might be easy. But if you say, I want all the files which are like matching this particular pattern and contain at least a module and bind to C, then this query has to be more complicated. The question is, what do you, how customizable should querying the model be? So what?
Well, why cannot we just export the model as JSON? It's just modifying the exporter, the printer, and then load it in Python or in Fortran conceptually as JSON. And Fortran or in Python, you just figure out what you want yourself.
You have your keys that you have to look for and extract. I agree with that. But there is a small complication in terms of what FPM does. I'm thinking in terms of VS Code, which is what we consider Fortran files and what FPM considers Fortran files. So currently the extensions.
But why is there a difference? I mean, if you're an FPM project, whatever VS Code thinks is a Fortran file doesn't matter. If you want to run it with FPM, the only thing, so the ground truth is what FPM thinks is a Fortran file is a Fortran file. And if VS Code disagrees, then FPM has to win. Otherwise, the project is going to be broken and won't build.
Yes, but technically speaking, so what you're coding on your editor and you assign a file extension to a certain language that might not be the standard one. So how do you have to communicate that to FPM? That's what I was thinking.
Then your
So
project
FPM
won't
will
build with
win.
FPM. So
FPM, sorry, go, bro.
Well, if you've told VS Code that .ifn or something is a Fortran file, well, FPM doesn't think so. So your project won't build with FPM. So it doesn't matter that VS Code thinks that's a Fortran file. It's not.
But it should.
Then
the way to do it is you modify it in fpm.toml. So in the VS Code extension, if you want some customized behavior, you have to tell FPM. And currently the only way you tell FPM is through that fpm.toml. So we can, or command line options, but fpm.toml I think is better. So we should just use that.
Yeah, so we could implement an option where you can set custom extensions, which will then be handled as Fortran files. We discussed this before.
Technically what I was saying. It's just editors can do that on the fly, so we have to watch for that.
So there are basically two things you have to communicate with FPM. One is the state of the project, which is entirely defined by the FPM toml file. If you open FPM project and say, okay, this project is going to have FF files as free format Fortran for whatever reason, then VS Code has to modify FPM toml to reflect this change. And then FPM is ready to go. And the other thing is, if you say, I'm going to use this particular compiler, this is a build option, and they are communicated by the FPM command line. They are not part of the toml file. So, so the other settings, so this cache file from CMake, this is the command line the VS Code extension has to keep track of. And you can have them as option. So
FPM has that response file functionality. We can keep all of the command line options in a file. VS Code can. So you can go, oh, I'd like to switch compilers. It doesn't have to remember the whole command time for all the options you've got set. It can put them in that file. That way, when you open it again later, it reads that file, goes, oh, here's what your options were the last time.
Yeah, and I think as a user, I would love that. If I want to know, what's being done behind the scene, and so if I set up some options in VS Code, changing some files, whatever, maybe I would like that, but but maybe some users would like that, but. Then the extension, the VS Code extension, should then save it to fpm.toml so that there is a single source of truth. And I would just add to what Sebastian said. I think the input to FPM is the fpm.toml and then the file structure, right? The file directory structure. Those are the two inputs.
We have to be careful if you select if you select your build settings and you say, this is my absolute path to G Fortran. then this is something I don't want to check into the project. This is something like a local cache.
Yeah, well, as you mentioned, compilers are not part of FPM.toml, so that's
Yes, but if we say we use the extra table and make an extra VS Code where we store these options, I don't think we want to check this in. So it should never enter either a response file, which could be checked in, or the extra table in the package manifest. Rather, it should go into a cache directory, which VS Code will find again if it starts up. It associates this with the project.
Yeah.
We have to, so we should really distinguish between build settings, which are local to the machine, and we should distinguish between project settings, which will be only recorded in the FPM topper file.
Yeah, I agree.
Yeah. No. No, I think that sounds good. I definitely have a better idea about how things should look like. Yeah, I don't know if I will be able to start on this, or will need to get some students. Oh, something, just everything went black. Or we're gonna need to get some students next year, which is probably the case. But yeah, at least we have the scene set up of how things should look like.
We'll work on this iteratively. I'm focusing with Fortran on MinPack now. We are very fast, very far, very close. Once we can compile MinPack, the next thing is I'll create the FPM package for MinPack, the SciPy, the old fixed format, fortunately, but that's fine. And then we have essentially Fortran in production, working on some production code, not some simplified code, actual production code from SciPy verbatim. And so these issues of interaction of the compiler and FPM will come up. We'll just fix them, as we kind of iteratively. And I do want to have the language server as well. I just haven't. I mean, we have some prototypes, and Yanis and we worked on it over the summer a lot. We know, I think, how to do it. We just have to do it. I didn't spend too much time until now. I really want to get Fortran to compile MinPack first and so on. Yeah. Really focusing on the compilation. But in the coming months, as Fortran gets off the ground, I want to have a language server, and we just, we'll create the prototype. We'll just have some subset working, and we'll iteratively improve it.
Yeah, exactly. I mean, it offers a lot of work packages in that sense that are the background of your language server will be, it's one task, but then everything else, which is the functionality that the user sees, are orthogonal work packages because they're different requests. Yeah, so hopefully in a year, like with partial involvement, it should be in a very good state. Okay, thank you guys. Okay, so I think that mostly sums up the FPM integration with VS Code. All of it is, we agree that all of it should lie on the heavy lifting should be the FPM and not the extension. Okay. Great.
Right, then let's move on to the next topic. We send in the NumFocus application. So is there anything which we need to further discuss on this?
Not really. They haven't contacted us, right? Deadline is 30th of November for contacting.
Okay.
So we'll keep an eye out. Now everyone should get an email for that, not just me. Okay. That's the thing that I asked them. And yeah, I'll let you know if there's an update on my side.
All right. Nothing to add from my side. I would suggest I close the public part of the monthly call, and then we can catch up on another project.